Okay. All right. Welcome, everybody. My name is Christopher Grant. I gave a version of this talk at DCAF back in early June, and I'm excited to share with you guys today a way to start thinking about AI systems with language that can help with really getting the most use out of those kinds of systems, and as an assessment tool, as a thinking tool, as a development tool. This data-driven community, is used to thinking in ontological terms. The AI community is starting to adopt more widely ontological framing for how the backend systems work. And of course, the actual delivery and development communities are starting to ask themselves, do we need ontologists on staff to be able to manage this coming transition? So hopefully today can give you guys a little bit of terminology and use cases to help in that space wherever you are. And then, as Lucas mentioned, the recording will be available later for those that will miss the end of the talk, or at my website, you'll be able to pull this down, a backup paper basically for this sequence. There will be 3 of them there that you can pull down later as well. All right, so let's go ahead and jump into this. So what is AI is like one of the biggest questions that I've been asking for the last 3 or 4 years, right? And I actually am going to try and figure out how to talk about this cleanly and stop using the word entirely, if at all possible. The systems that we think of as AI today are not intelligent. They are artificial, and they are software programs that follow rules. But this is a story about how does all of this really work and what does intelligence really mean? So I am a sci-fi and fantasy nerd, self-acknowledged. I've been working in the space community my entire career at the mix of embedded hardware and software systems that turns out to be very relevant as AI systems make that easy to manage going forward. So you're going to see some flavors of that throughout today. But we start today with a quote from Terry Pratchett, one of my favorite authors. This is a conversation about the third thoughts here. They are the things that take over us. They are the things that are, how do things really work, right? And as an ontologist backing of, how do we really define things, relations, etc., in real systems? Over the last 20 or 30 years, it's been easy to get caught up in the taxonomy of how to represent things in data systems versus the real ontological and semantic meaning behind those things. And it's going to push a burden on us, our friends, families, kids, employees, coworkers, bosses, to start thinking a lot harder about what are you really trying to do. Because the advantage you can get in throughput when you both understand what to do and have the tools available is 99% plus, which leads us to that bottom bullet. I continue to state it, and I'm going to stand by it. I know it's bombastic, but I will claim here and show you guys some examples over time. I believe that systems engineers and architects that understand the 2026 variant of an agentic software stack will be infinitely valuable by early next year. To break that apart a little bit, right? The people who are trained and experienced thinkers of how to build, how to design, build, test, validate, and operate systems are the thinking structures that AI systems today, these agentic models, these prediction models, they rely on very clear written contracts. And the better you can write that contract for what you want and get what you expect out of the other end is a systems engineering process. The architect level is how to do that at scale, and how to do that over multiple domains of concern, over multiple disciplines of fulfillment. And that skill set When combined with the 26th variant, and I say that specifically because early last summer, most agentic systems you could subscribe to or download would regularly score very low percentage throughput on many of the benchmark metrics. And since, let's say, late last spring, there was a generational turn in the early summer, one in the late fall, another in January, February, and you can feel these accelerating, another in April, May, and another happening now in July. And so we're down to about an every 60-day cadence of multiple digit percentage improvements in capabilities in models you could download from the internet, and that enterprises and organizations need to start considering who and how are is their data and inference needs going to be met. And as we look at like the hyperbolic circular investment system of Wall Street, the key is to identify that whether or not a company has made a good bet on using a ton of water on yesterday's data center technology or not. So that bubble potential notwithstanding, the fact that these capabilities are getting better at smaller sizes means that quote unquote regular enterprises are going to start feeling obligated to own the data center, to own the provenance, to build systems of systems that can do this stuff. Because when you do, a 99% reduction in cost to deliver sets up this infinitely valuable prospect going forward. And figuring that out is not something that can be ignored or waved away. It's not something that can be dismissed as hype. It's something that can be done if it's done systematically. All right, so interest of time, let's continue to press through the stuff. So a little bit about me. Why should you listen to me at all? I joined the decaf community actually relatively late in consideration of their kind of process here for the conference in early June, which I was super excited to be able to go to. And I found my people, I feel like. I actually did an ontological coaching program 10 or 15 years ago, then learned very carefully how not to use that specific language in my everyday business life, but used it nonetheless in the national security space regime, building strategy, doing business development, doing program management, doing capture management, doing strategic research and development management to the tune of a few $1,000,000 a year, up to 10 over the last decade, including capturing several $1 billion worth of activities, both design, build, rebuild, operations, maintenance of system enterprise grade capabilities. Last fall, I was struggling to get the anchor I needed to make progress in this kind of new generation. And the AI part of this story turns into how can we really leverage this thing that has too much money to ignore to really solve the world's hard problems. My quote here at the bottom is one of the things from my coaching days that I repeat esoterically to the people who work with me, but is incredibly important in this day and age, and increasingly so, I find, as I spend time with both AI and people going forward, that there is no value in speaking and only in the listening that it produces in the audience. And the meaning behind that, right, is I can say the things that I'm saying, and it sounds to me like I'm expressing a point that makes the point that I'm trying to give to you. But each of you on the phone today or listening later, you bring your own background, your own history, your own experience, your own lexicon. I'm going to use a word that means a thing to me that means something else to you. From different communities, you will have your own understanding of the rules in your domain. And when I say things are definitely possible, you will say, well, not here, because here, this rule changes that. And the key is that as we think about how to communicate with others and build resilient systems going forward, focusing on the listening we intend to produce will help build better solutions, right? What do we want the thing, the computer, the agent, the team, the person, the organization, the boss, the customer, the employee, the son or daughter, right? The child that we are trying to teach. What is the listening we're trying to produce in them? And then be able to shape how we speak to bring that forth in them rather than to justify speaking on our own behalf. Okay, so I'm going to start here with a little cue to the ontology group because I'm going to kind of use the structure of an ontological system going forward, but talk less about the specific terms of art in it, which I think you'll see as we talk about the anatomy of an AI interaction to kind of bring ontology space into usable capabilities. This, as an example, is a map of the BFO, basic formal ontology, that maps all things continuance and occurrence into entity, things that exist, happen, or can be referred to. BFO is on here because there are several different formal ontologies, like at this kind of global scale, that data scientists, data engineers, and data system architects have been using in different domains. BFO notably is both an anchor for a large biomedical set of conditions called, I think it's actually this is going to be wrong, but I'm going to say it anyway, the biological ontology, one biological ontology, or a different acronym. But the OBO Foundry ties together a large community, and BFO is also been adopted by the Joint Enterprise Standards Committee as the core ontology anchor for the DoD and IC enterprises. And so as we think of data systems, both commercially, for software companies and the things they do in the medical community, as people continue to need as much help as they can, and in global defense and security context, as we see opportunities there from a business perspective, being able to understand how BFO is organized will continue to become more and more relevant over time. Even the semantic arts team, right, did a just to BFO crosswalk mapping that they've published some papers on, and I'm trying to help them with some of my findings and capabilities to make sure that organizations that have been working with companies like Semantic Arts and the GIST ontology family have easy mappings to be able to translate into this new future going forward that allows for this cross-domain translation. All right, there's a lot of words on here. The white words are the actual words of the BFO ontology, the actual classes. The subtext is the explanation, okay? As a brief explainer, BFO has 35 classes arranged like this, where this is going to get to my physics is physics quote on the next page, where there are things, there are situations, there's an environment. And fundamentally, everything we think of that humans touch is part of this process system, where there is a story about things and their situations with respect to other things, other situations in an environment. And the rules of that interaction, the things that can happen or can't happen, should or shouldn't happen, will or won't happen, translates all over the place. It happens in physics, matter plus energy equals system, right? F equals ma. You get lots of things that can happen in the physical environment. It happens in language, okay? Nouns plus verbs and the rest of the parts of a sentence give you the setting is the environment condition of a story, right? So a subject and its verb, its action in a situation is the same pattern. And it all kind of can trace up to these things that you can build into data systems, right? This is a conversation about AI systems and how to take them apart. If all of this sounds like black magic to you, there is more research to be done, and take your time at it because it is difficult to dive into quickly, but it is nonetheless important to understand as we think about how to do this stuff going forward. Okay, so a little bit about my company. I told you I was I left BAE Systems last fall. and have been focusing on how to leverage, agentic technology to solve really hard problems in my historical domain. And then, of course, once I did that, realized that I could take the same skills and capabilities and apply them in other domains of help where I want to do that. So Hyperion Fulcrum Group, Hyperion Vector Systems is the website that you see today. The Fulcrum Group piece is going to continue to stand up here in the near future, focused on the commercial side, where the Vector Systems continues to serve kind of my historical domain of expertise. But I've talked a little bit about the physics is physics stuff now. And to just be clear here, each of these buzzwords on systems engineering principles or design principles is actually a contract for the behavior patterns and the kinds of system design considerations that can help make robust and flexible systems. I once took a leadership metric. I forget what those things are called. That's like the Myers-Briggs test, right? And there was like 3 axes of personality type on it as well. And I managed to peg all 3 of them, which doesn't surprise people that know me well, for assertiveness versus passiveness, for flexibility and rigidity, and for decisiveness or want to study the variables. As I pegged all 3, I mean that I was able to comfortable making decisions, comfortable being assertive, and comfortable being flexible, which meant being able to change my mind, but that the standard was pretty high because I would make my mind without input, without it from others. So in that story, these kinds of principles are embodying the same things of systems that can enable quick decision making, that are flexible by construction, and that are comprehensive in the content that they can capture, and that resist the sampling tendency and of the hallucinating chatbots, which is what most people, the colloquial term these days is chatbots will hallucinate. What they will do is they will sample and infer whenever possible, because their core charter is not to respond, and it is not to design, and it's not to build. It is to continue a conversation in a generally positive tone towards a seeming conclusion as quickly as possible. The commercial grade tools are currently being optimized for cost, not capability, as these companies try to go to IPO. So the companies behind them are systematically trying to reduce their own cost by reducing capability just enough as they maintain their commercial edge to be able to maintain their commercial position and justify their IPOs and their development costs and the amount of money that they have to spend in order to stay on this frontier edge. The hallucination piece is a neat term that people like to throw out, and it actually leads us into the rest of the talk, which is companies that have figured out how to do this are deliberately using terms that can obscure the situation as much as possible, either to hide their own uncertainty or to make sure that their competitor doesn't really get to the basis of what is actually going on in a way that can be repeated. So let's see. I'm going to skip over some of this stuff just in the interest of time because you guys want to see these things. I have a core philosophy about how to organize developing systems, which involves managing each of these kinds of 3 primary concerns over an integrated data framework that I'm happy to talk about if you want to reach out to me and discuss that later. But let's get into AI systems, okay? Here we are looking at the core graphic of the talk for the next 20 minutes or so. What I'm calling the anatomy of an AI interaction. It's a pretty good draft. I'll say it's a draft. You can see version 4.4 means I've been working on it for a while and I need to continue to optimize it. But what you're looking at here is an ontologically distinct, is what I'm going to call it, a functional block diagram of an agentic system. And when I said up front, systems engineers and architects who understand the 2026 agentic software stack, this is what I'm describing. Today, most people, when they use these systems, they are the human on the left. They type their little purpose into Claude or ChatGPT or Grok or Gemini. They put it into that top box. The system does what it does. It puts out the answer. They get response output, and they say, yep, look, I used the AI system. I put in the thing, and then it told me that. And when I put in my question, my very, very complicated, ontologically messy question, I got something that is not what I wanted. And as a systems engineer, and any systems engineers on the phone can tell you this, that's not that is a requirements problem. That is, you can call it operator error. You can call whichever polite version or impolite version, depending on your audience, depending on who you're talking to. But when you say the response, it can't, the systems can't do that. It doesn't do that. The ontologically more precise statement might be, you didn't use the system that can get that out of it. And you didn't know that you didn't have the right system when you did that, because the understanding of what to look for and what to use is not sitting there available to you every day. Because fundamentally, this is a new engineering discipline. As I pivoted from, space system architecting from, ground through space systems, the entire hardware and software mission operations stack, including all of the fulfillment and supply chain side, right? The idea that AI design, system design can just be picked up by any one discipline, right, became immediately obvious that that was not the case. AI systems architecting today, I argue, is a mix of cognitive theory, systems engineering, system of systems engineering and architecting, which I argue is distinct from the prior, software engineering, and computer science. And I'm going to say data science and engineering, even though I have less familiarity with those two, I will admit. So we are crossing some version of 7-ish discipline, like strong disciplines that many people specialize in one of those 7 and say, this is my entire career. And that combination of disciplines as a structure, in order to be able to field competent and constructive systems, is actually, this is where the space piece comes into play, and where this kind of system enterprise thinking comes into play, is when you're used to a system having that many disciplines as part of it, it doesn't feel scary, it just feels inevitable, right? Systems of significant capability have lots of pieces. And if you can build them coherently, it is not easy. It is often expensive the first time, and it can be replicated much less expensively depending on the customer market and the use case. And this is actually an overall system design and development architecture that there's a lot of people who are actually really familiar with. But it requires understanding that connection and not being so busy that you can't take the time to learn an entirely new engineering discipline. It's unfortunate that is true, but we're in this kind of mixed stage where the obvious truth is there, but the people who are most able to take advantage of it are the most busy, stuck doing yesterday's design system. So you've been staring at this graphic, you've been listening to me, you've been doing one or the other over time. The listening that I've produced is questionable, and I hope that reading or listening to the webinar again later will help add to the recursion of your learning process here. But let's look at what we're looking at. So most people, they are people, they type, they get a response. People these days are very used to doing prompts. You are a software engineer, please give me a really good software product, right? Companies are building lots of capabilities around prompt engineering, right? Think of Lovable, the company that helps you build your own apps for whatever purpose, right? They take your prompt, then they break your prompt down into a series of instructions for the model to write various scripts in the language of whatever host system you wanted. Then it puts them together, verifies that nothing is broken according to its logic, and then hands you it back. You try it, it works for you, and then immediately doesn't work as soon as you show it to anybody else, which is the validation failure that one would expect when you didn't design a validation campaign. This is a systems engineer speaking systems engineering V&V planning as part of the upfront design process. Here, though, there is a layer when you get into these agentic interactions, and I'm just going to quickly talk through everything, then I'm going to go through the charts and then leave time hopefully for a few questions at the end. the blocks here. So the first thing that so my argument here is that every agentic system has these responsibilities and functions, and that most hide them or don't have them or skip them depending on their quality and depth of capability. Okay, so you can easily skip your way right through the process and not do things by passing, in equals out, or you can implement all of them. I will tell you that I've reverse assessed, analyzed, as an example, Claude's infrastructure, and it's like 5 or 6 copies of this on top of itself, because of the way that they've structured Claude.ai via browser, via desktop, via design, co-work, the Office 365 integration, and Claude Code, and the API access are all unique instantiations of this harness that have different tuning knobs on each of these boxes, but all use the same yellow box in the middle, which is that model space of Opus today, now Opus 5, Sonnet 5, Haiku 4 point whatever is still there, and Fable, or the Mythos use case for those customers who have access to that. So the model is one of these pieces. The rest of these pieces are the things that actually define the performance. The data point at the bottom has a specific reference. You can look it up, and I think there's actually like a deliberate link to it at the back of the package. That the harness, the system around it, actually got more performance out of a model in this test than the model itself did, right? The ability to run the black box prediction engine over some serving condition with a quant metric of like how big and how much processing power did we give it when asked a question. When we shaped the rest of the system, this is not me, when this team shaped the rest of that system, they were able to more than double the score by shaping the inputs, by shaping the outputs, by connecting it to real data and real systems. And that's what fundamentally each one of the rest of these boxes is doing. The instruct box is actually an instruction architecture. My system in my Claude team, my Claude work, my Claude team page has 10 layers of control points for people using that system. And if you think that there is only one, then there are 9 more that you are not using. And I'm happy to explain that if you want to talk about it later. But the instruction architecture around these tools can be simple or complicated, but really, really shapes how the rest of the system can work in an automated way. Input guards, especially the commercial systems, have a lot of things that they can't do. Fable is a famous example these days of not doing anything that you type software into or bio into, it seems these days, without dropping you to Opus. But also it's a security thing. It's also injection guards, making sure that you can't, especially if you field commercial products, that you aren't opening yourself to access vectors. So there's a multiple front-end filtering process. There's an instruction architecture. Those things can set up for context, right? A query, the human says, I want to do something, or gives it a spec, a 10-page or a 100-page or a 200-page set of requirements. And that context needs to be turned into software organized information. That's the context box. That gets embedded with a vector cosine function. It can be ontologically classified. It can be classified by any data architecture that you currently manage. I'm going to argue that BFO grounded ones are fundamentally stronger. I would say any well-designed ontologically grounded system is fundamentally stronger, in a nod to the investment and time that the GIST team has put into their business-focused ontology structure as an example. But you use that then to create these data conditions, and this is the data scientist piece, that go connect into RAG graph database spaces of where is the information relevant to the thing that I'm trying to figure out. Right, in a military, in a system use case, in an upper business case, leaders always say, I want the information I need to make the decision. That's what your job is to bring me that so that I can very clearly see, then take my context of the world that our business operates in and the business that our business is. All the concerns that you don't carry, I carry all those concerns, but you give me the data that I need to say this one. That decision authority is based on having the right information in front of you, and notoriously can go very wrong when the wrong information is presented or a gap in that information is presented. And this is going to be the power of these ontologically grounded data retrieval systems, not just semantic similarity of a sentence, but ontological distinctness of ideas, authority, and capabilities. The infer block, famous one, model, Opus, Gemini, Grok, Quen, where are we? Nematron, Kimi K3 is a big popular one, scary right now. The Chinese open source conversation versus what are US companies doing and where are the pros and cons of these architectures. I ask people all the time, huggingface.com is a community resource for this kind of development, this self-hosted development, open weight, open source. And I say, how many models do you think are on huggingface.com? How many things are the things that people use? And people give me these answers. They say 10, 5 or 6, they can name the big commercial ones. They say 10 or 20, and they think that they're like, stretching. And then there's the people who are like, oh, I know, there's at least 100 or 200. And as of March, and I don't know the current statistic, there was 1.4 million variants of models on huggingface.com. You and I can both stand and look at each other straight-faced and say 90% of those are inarguably trash. But that left me 140,000 things that are different flavors of sub-optimization of these kinds of functions. And the question of which one of the largest, most expensive frontier models is the best for your company or your team or your family or whatever is going to disappear under the fact that each one of these knobs can fundamentally change the map of what's available. And that systems should be designed around many of them, right? People ask me what model I'm using. I don't know. I have 45 of them in my architecture right now. And if you think I'm exaggerating, I am not. Each of them sits with a purpose in a place on this map, several of them in different domains with different optimization conditions, with tuned contracts, with tuned weights. Sometimes I'm learning a lot about how to what is manipulatable by a person versus a team. And without having to train my own frontier model, the ability to have each of these functions with an optimized set of software code is plug and play software design. All right, so let's keep going. So thinks and hooks. One of the reasons I use Claude Code instead of Claude.ai or many of the other systems is because of its hooks system, which creates entry points in the processing architecture for which you can insert a script. And as an example, every time that it says, you're right, I have a sycophancy flag that says, stop, take that out, don't do that, and gives it a set of instructions and then causes it to redo the term. It is not context efficient, but I prefer to read it without that. The more valuable one that I find triggers almost every day, and I hit somewhere around 100 of these flags per day in everyday use, is my research before build guard. Agentic systems can just decide to go do things. And if you give it and say, well, what about this? It can create its own interpretation of the answer, decide what to do about it, start working on it, and find itself so many steps down the wrong path that you went to get coffee because you thought it was doing that. And you came back and said, none of that makes any sense at all. Now we have to go find out how to backtrack all these files that it wrote and what did it touch and how do we do these things. There are data points, and you can research them, about larger agentic systems regularly decreasing in quality 3 or 4 months after they're created, which is a direct dependent line from what happens when you let incorrect information continue to poison the system as context, right? I find somehow it always will find the file where it wrote down the wrong justification for something, even though it did the right thing. And if I don't fix that in writing, that will be the one it pulls out of the archive. I don't know why, it just always seems to be the case. It says, well, since this is why, now this decision is obvious. And I say, where did you even get that from? That document that says this is why was like complete garbage. And instead of taking the conclusion and the obvious, like before that step and the after that step is the line, it took the one anchor point it thought was convenient to complete the conversation and started moving in a different direction. Agentic systems are notorious for that. This is another part of the hallucination thread. It isn't hallucination. It is actually a systemic process where math and software code follows its instructions. It doesn't have the instructions you think it does because you don't have the ontological distinction for the instruction set it does have. Neither does your team, neither does your employees or your bosses, or again, your family, friends, coworkers. The ability to understand what it will do and the ability to change the inputs are things that can actually help you very systematically change those outputs. So the hook system lets you actually add deterministic functions in the middle of a model process before you get an output. And you can have it run tools, right? A lot of people make the category error of giving a large reasoning model a tool test, and they say, look, AI can't do this. It doesn't search the database. It's like, because you gave a system whose instruction is complete the turn as fast as possible, a question it thinks it can answer. So it did. If you give a system the data first, then guess what? It tries to summarize the data that it got on its way out. And maybe you don't need a big reasoning system if what you want is an answer grounded in a specific data set. The reasoning model can come in towards the end in this assemble infer stage where you can bring it the context, the data, the tool access, the information, the restraints, the authorities that you want it to have. But if you put the reasoning engine in front of it and expect it to perform good logic on the way, you will find yourself disappointed, I think. I think many people do. Then at the end, we get to this assemble stage, put all of it together, get ready to give it to the human. This is where at the V&V stage, a systems engineer says, so you verify that you met the requirements, which was the input. But what's actually happening in the verify block in most systems is there content to export? It has no way to connect the output to the input because there is no system of knowledge between the input and the output. It's purely predicting the next text token. The verification is there is things here. And the validation that happens in most of these systems are, did it trigger one of these output guards of things I'm not supposed to write? And if it didn't trigger, I'm not supposed to write this, and there is text, it goes out. People like to imagine that there's an engineer there that said, is this the answer to the question? Now, of course, having no understanding of the actual ontological purpose of your question, because you didn't write all of that down, there is nothing in there that can check that condition, and so it passes it out to you. If you design systems, however, with that kind of process in mind, you can create these functions where the whole system is following a regular process and get much stronger capabilities at the other end. So this anatomy is fundamentally true for all agentic systems, simple to complex. In simple systems, they have zeros in these boxes. Complex systems have multiple versions of these boxes. I mentioned the different harnesses. I mentioned the relative strength of the harness versus the model. Each of these things, though, are simple logical questions that you can understand reading them and start asking your teams these questions. How does your AI system work? How does it handle this? How does it handle that? Are you investing in technologies to enable these kinds of things or those kinds of things? What is the data architecture that you're managing? How do you observe the process to check and verify that the output is consistent with something? Is it all generative? You know, have you got any, you know, where is your checks and balance system, right? How do you assemble the data? What is your verification and validation process as a team, both in your development of your tool and in how the tool helps me, right? Where should I put it and what else do I need to wrap around it? And the rest of those services, you might be shocked to hear most AI companies can't even describe, let alone offer. So beware of what you sign yourself up for. All right, so I'm going to step through, let's see, I've got just a couple more minutes. And I'm going to step through these charts relatively quickly, again, anticipating that people will have access to the webinar and be able to kind of go back through, find some examples of things they can use as references later. But fundamentally, it's the kind of textual support for the narrative, right? So the idea here, when I say don't walk it as a pipeline, right, there are different kinds of functions of things that happen, and recognize that those functions both relate to each other and have different purposes, inputs and outputs. Because if you start designing an AI system from the left side and the right side, and you don't have these five kind of we'll call it a work breakdown structure for those familiar with this term, right? This kind of structure of responsibility, of capability, then you're going to start finding yourself not realizing that RAG is showing up as material substrate when you're like, okay, well, hold on, where is the database? How do I call the database? How many network hops do I have? How much CPU, how many users can access the database at one time? Right? One fun thing you learn as a solo founder is when you add people to your system, they crash it because you don't have a memory manager. And then you build a memory manager because you have an agentic software buddy that can help you do that. And then it turns out that you're the one that was crashing it the whole time because you gave it a large ontology build and it was actually your own thing that was the problem. And you have to filter yourself anyway. It's a whole thing. The point is that you can use these structures to figure out where are problems, opportunities, and design considerations. AI is a black box. This is the category error problem, right? The model doesn't act. The harness is the thing that acts. This is my comment about AI can't do that. And I say, well, some people are using it to make whole movies. So if you say it can't make a PowerPoint chart, that is a limitation of your ability to use the tool you selected to create the product you desire, which is a process problem with multiple potential failure points, not a technology can't do something. And there are dangerous amounts of research happening where people are making declarations without these distinctions saying AI can't do these things, where they have set the test up specifically in a way that will absolutely guarantee their failure with no understanding or awareness that that's what happened. Capability classes, this is going to be one of the other documents on the website. The capability class is a conversation about where you are and how much you understand about how these systems really work. Just to briefly kind of highlight this, I'm not going to spend a ton of time let me just use this one. So the idea here is that the 11 kind of boxes of the anatomy map to these different classes where different kinds of users operate in different ways, right? People who build open source harnesses are using all of the steps in the middle. Subscription users to Claude or ChatGPT are just using the beginning and the end, and everything else in the middle is a black box. But as you look at like whether you feel comfortable in agentic system conversations, the ability to figure out how to do these different steps are where you start getting into, how much capability can you really expect? And the organizations and people that are getting a lot of utility out of AI versus the people who are piloting prompt layers packaged as software tools don't even understand that they aren't buying even close to the right thing because it's so complicated. And that the right thing actually is a larger obligation on their own data and management architecture than it is on the tool set. Because you can chunk your data so many different ways. And if you don't understand the common traps that make the output useless, you will find yourself with a whole bunch of weird conclusions that don't make sense. And then the need, because somebody told you to do AI something, and then a lot of money invested in systems that fall apart. Grounding is the design principle. So the key here too is that when you have this kind of architecture map, and you can frankly take even just the language from today and start asking Claude and ChatGPT about like their capabilities in those areas, about a tool you like, about a tool you use. The key is that when you can ground this architecture of a system, you can start figuring out where the problem is. So instead of saying, I don't know what's going on, it gave me this random answer. Once you can start recognizing, you're like, okay, well, that random answer happens because this block does this, and I didn't give it that before that happened. And not everybody is going to be able to design agentic software architectures, but the teams, the people that can, and the teams of people who need to be able to serve these services for companies really need to understand not just how everything is built, but once you do, then it's much easier to understand where to go and find problems later on. So the key here is that once you kind of have this architecture, you can start to assess your AI capabilities, what others bring to you, right? The pattern is the same thing, right? How is your data organized? How are people trying to help you? How can you decompose these things and say, how well do you understand this yourself and others? It can really help strongly filter whether you're getting sold up a creek without a paddle or not. Here's some specific examples. This is a specific example. The documentation set for Claude has 75 tuning knobs that you could use if you knew about them. The authorable capabilities, those are things you can write. The instructions are in their training manual. If you have ever seen all 75 in one of your YouTube videos or found them all by happenstance, you win a prize. Tell me the story. If I believe you, I'll send you a cookie. The point is that these systems are incredibly complicated, but they don't talk about them that way so that people don't get scared by the complexity and instead focus on the potential of the utility when given specific examples of things that have been designed on purpose to be very strong through the entire harness web. So that wraps it up for me. I'm bringing this back up for a minute to just remind everybody, right? This was a data software, computer systems engineering and architecting map, right? The intent of it was to be able to give you guys some structure and words to think about how to understand your own systems and others, and recognizing that when people say model, the harnessed model is the system that most people are not comfortable talking about in public because people in public are very comfortable saying AI and moving on. And if you really want to be one of the people who's getting or helping teams around you get actual use out of these kinds of systems, understanding how to talk about it in practical, pragmatic terms that are ontologically distinct with others and the systems is incredibly important. Let me know if you guys have questions as a follow-up. That's it for me.
Chris, I see we have a question from Rishi in the chat.
Sure. Let's see. Oh, I need this one.
I can read it to you if you...
I can grab it here. Let's see. Use of ontologies to structure data layer for developing AI systems lead to better outcomes. Sure, references. So the use of, an ontology, especially a published ontology or an ontological structure is, and I showed the BFL map early, is a way to have some measure of certainty that you have captured the responsibility set of the things and relations that are relevant for your concern, for your business, for your enterprise, for your activity. Using ontologies to ground data structures means that you can also find the patterns between different systems much more quickly. And so the ability to say, well, we do this thing. Has anybody tried to do this at the company before? And being able to have the ontological distinctness of the decision and the authority and the data and the action and the tool set that was provenanced for a specific purpose is like only the last piece is different. And being able to find those patterns in your data when you have that common data layer structure is powerful. I will say, and I think Lucas and his team can probably talk to it, right? Companies have been building data systems for many years. The power of having that be ontologically grounded has been proven over and over in regular use, and it's getting more important when agentic systems will make assumptions based on data systems that if they don't carry ontological distinctiveness, can carry semantic category errors that people do not understand. And as an example, you can say a contract is this. Let's use like will and shall. Okay. In government contracting, will and shall are very clear terms of art that mean very specific things. A contract term that says the contractor will, the system will do something is usually a will be capable of something like. And so as long as anybody can say, sure, then that's the standard. When the contract says this statement shall do something, it means that there is a hard level of verification, especially if there's a number on that shall, that is required in order to verify and fulfill delivery. Those two words do not carry semantic differences in any embedding system that I have found, unless you're using a ton of parameters from a sentence structure perspective. And being able to very specifically describe them as different, you can say, well, I built a data system that clearly defines those two terms as distinct. And I say, great, you've followed ontologically distinct principles in your data system design, and you're likely to see success with that. Like, congratulations. You know, the need for it to be a named formal ontology is not the same as the ability to say the distinctive nature that means the entity's role and authority with a situation in its environment is the relevant structure of information. As long as that pattern maintains, then you've got strong data systems. In the context of a prompt and OWL syntax, so quick answers there. In the context of a prompt, right, the ability to be comfortable using ontological terms means that, you know, my prompts tend to carry things that look a lot like system specs. Okay, they define the actors, they define the inputs, they define outputs, they define requirements, right? I showed you guys the systems engineering buzzwords: axiomatic design, pattern-based systems engineering, human-centric design. These are human factors, GUI, user interface things show up in my spec documents for anything, for a toy, for a customer product. The use case, okay, I want to use it like this in this context. Have that conversation and use all 200,000 to 1 million tokens of context one time, and then put that use case into one section of your input in your design process. The OWL syntax in particular, that syntax is limited in how it carries ternary information and relations, which is why first order logic systems are kind of being wrapped around the OWL format. And this is where Shackle and Sparkle are going to start to come into shape a little bit more as that becomes easily automatable. There is absolute strength in how ontologies are currently shared in an OWL frame. The OWL frame is not sufficient for every use case. And so there is usually appended documents, right, that come along with those things, axioms and relations that are outside of the standard OWL term set that need to be included. So being able to capture all of that in one action is something I expect the community to get better at doing over time. Let's see. Prompt OWL. Linking ontology elements to their natural language definitions. So an ontology is fundamentally defined by its definition, right? So a formal, let me say a published ontology, right? A formal ontology of any flavor, formal level, mid-tier, domain specific, entity specific. Okay, there's a hierarchy there. A business at the entity level can be part of a domain. They can be part of the mid-tier that kind of classifies things, like this is where the OBO Foundry and Common Core ontology within the DoD and IC frame will live. That kind of brings many similar characteristics with same terms. When you say linking them, each one of those classes, entities, continuance, occurrence, and relations has a code. The code has a label. The label has relational rules that it can follow, that it must follow, that it must not. This is where the first order logic terms come into play. If, and, but, or, if and only if, then, is, part of, consists of, again, must not, can, cannot, will not, shall not. These are all kinds of relation terms that are structured as part of the rule sets of the published ontologies. I would expect companies to be able to adopt well-structured ones as much more powerful ways to take advantage of that information structure sooner than designing their own. but as they get easier to do, there will likely be more, and I know Dave McComb did this, right? He has like the schools of ontologies and like the use cases for them, right? The principles of them are likely to be the things that stand the test of companies having the flexibility of building their own more quickly in an agentic future, and being able to say that they're consistent with this set of rules, principles, and schools of use and just design and development. Those will be the things that are more likely to persist. Skills like Claude, superpowers, rating plans. Oh, absolutely. I actually used the superpower skill set a lot early. I eventually superseded it with something that had quite a bit more specific structure to the kinds of things that I was trying to do. But the ability to just like build another copy of it is to understand the structure of how your domain or company builds things, right? So if the superpowers rating plans, there is an author. He has a GitHub community that takes inputs and PRs. That is the representation of a zeitgeist of what a good software plan looks like. Okay, which is not the same as what everybody uses Claude or ChatGPT or Gemini or Grok to do. And so if you build hardware and you're trying to figure out things, if you are looking at data only, that gives you some kinds of things. If you're trying to build a commercial application, you have different requirements in those plans to get you to something useful on the outside. And so superpowers rating plans is a contract, a specific contract. You can open it. It says, follow the steps. If those steps are better than having no steps, they are step function worth of value. Once you've hit that plateau of the thing you can download from GitHub without trying, then there is a whole nother 10 layers of step function of capability of how to design systems well in your implementation scenario for your use case and customer set. And usually companies have their own rules for how they work, either written down or more often through experts at the company that do somehow manage to use the system better than everybody else. And it's those kinds of lessons that are going to be the important things to maintain, to capture, discuss, and train people with over time. Training is one of the biggest outputs of this that, I have little kids, they're 8 and 5, and I'm excited to teach them some of these techniques so that as they get bigger, it's not foreign to them that these kinds of things are happening around them. And the training system for people 10 to 25 right now is more scared because there is no system taking care of anybody these days, right? In the early 90s, when PCs were taking over pen, paper, and calculators for how to put a desktop on every computer, companies were sending their people to training courses. Pensions existed for those that could not adapt. And neither of those things are common business practices these days. And I think that training condition is going to be the thing that will separate good companies and places where people want to work and be able to really bring the best of human capability forth. And those that find themselves trapped at lower levels of the capability map and not understanding why they couldn't figure out how to use AI like everybody else did. People still are the forcing function. Accelerating the capability of your skilled teams. You want to understand what the AI pilot is that you need? Build the system that can accelerate and reduce the cost of your most skilled people and sub-teams. The rest of it will figure itself out over time. Okay.
I've got a question for you, Chris.
Go ahead.
In your experience, the harness you've been talking about,
Mm-hmm.
what's the lowest hanging fruit for improving its overall performance? And then on the other hand, too, which parts of it, if you improve them, would make the biggest difference, even if they aren't the easiest ones to improve?
Sure. So the easiest thing to change fast to get better capabilities, like the person mentioned, like John mentioned about like the superpower skill, is using a structured process in what I call the instruction architecture layer. Okay, which is recognizing that your task is not ask a question, get an answer, but that your task is a systems engineering process where if you write down the requirements of what you want yourself or with the agent like working with you, people say, well, I use this prompt. And I say, my prompt is a 3 or 4 hour session across 5 or 6 threads of design that all get written into their own markdown file that then gets merged together under one markdown file that describes how I want the system to be used, how I want the tool to be used, where the data is coming from, do the research up front. Every time I do it, I always pull a roll skeptic, right? You can use a second model. These are actually like, they are straight up the classes of the capability map. Let me pull that back up again really quick. You're asking about like fast versus powerful. Let me share this again really quick. Okay, so fast versus powerful. The question is, where are you in this story? Okay, the first things to do are the prompt into instruction architecture, which means that you can use those prompts recurringly. And a prompt can be, right, a spec is a prompt. It's the input that drives structured output. The ability to have a model check another model, that's one of the most powerful things you can do, is get it to, especially if you use, you're using one system, Opus versus Sonnet versus Haiku, and ask all three of them. If you're using Claude Code, you can ask, I love asking Opus to say, give me 2 different Sonnet subagents with the exact same prompt, one high temperature, one low temperature. Okay, we talk about ontologies of agentic systems. Stay tuned. My initial draft 0 had a 600 entity ontology family for agentic software architectures that I'm trying to get community friendly here over the next month. And it's going to be bigger than that. And I know that Dave McComb does not like large ontology families and does not recommend them, but I promise that the ontological distinctiveness makes it worth it. Because it's a complicated engineering space. So it's a whole thing. So Lucas, the short answer, right, is that the ability to create these structures around the harness functions is both the easiest thing and the most powerful, right? Because what it really turns into is the ability to tune them all is the powerful function. The ability to understand that they all exist is one of these step function things. And say, actually, as long as I can make a list of how I'm doing each of these things or want to do them, what you will find immediately is that the answer to most of them is question mark, question mark, question mark, some kind of very generic bullet that you really don't understand at all. And as soon as somebody stands in front of you and starts using terms that you don't understand, tell them to stop and try again. That the ability to use plain language exists. Here are some examples. Pull the graphic up and say, explain this. How do we do this? How does your tool help me do this? And just kind of like force the check function against common language instead of letting buzzwords rule the day. Because every company is using a different word for one of these things. I mean, Claude right now, right? Design comes out. Cowork comes out instead of Claude Desktop, instead of Claude via browser. All they are doing is picking different flavors of things, right? Claude Design is a different instruction architecture over the same map in the middle against a RAG focused on the design content instead of the world, right? The cowork function has a lot more tool and execute off ramps before the inputs get to Opus or Sonnet in the middle, so that the tool function works better when people are trying to do things, right? The Office 365 add-ons, Microsoft Word, PowerPoint, Excel, they are like a pure tool in front of a tool and execute layer in front of the reasoning engine that has every rule for what to do with Excel. Notoriously, I don't believe that they actually gave it the PowerPoint instruction. I have yet to get one to work correctly, but that's PowerPoint Rangers near and dear to my heart. Know a lot more, it seems, than Claude Design does about how to build PowerPoint charts. But anyway, so that's some of the answer. Does that make sense? Right? Just being able to ask the question and take it apart That is by far the biggest piece. And then being good at it gets you even better down the line.
All right. We have any other questions? If not, Chris, how can people get more information or follow up with you about any questions?
Sure. So you can reach me at cgrant@hyperionfulcrum.com, at hyperionvector.com works as well. You can find me on LinkedIn. I'm gonna set up a beehive this week and start kind of putting some of these things through as like these kind of explainers of how these systems really work. I've got on there ability for me to have a quick conversation with people coming out of the forum. I'm happy to just set up a call and have a conversation with anybody who is able to listen and see the video. But there's more formal ways of stand-up conversation. There's a Hyperion sprint of give me access to your data and I'll help walk you through what this really means in your context, because that is really the thing that is helpful for most people. But you can reach out to me via email through the website, and we can share information and NDAs, or we can just talk about ontological system design as, again, offshoots of the community. I'm happy to be able to share some of this expertise, and because the thing that I think I have that is the coolest is something I'm also almost certain I cannot prosecute before it becomes obsolete. And the point there is that the future of all this stuff is how it helps people serve purposes, accomplish conditions of help for each other in the course of whatever their responsibility set is. That's fundamentally what I'm trying to do, and what I'm out here trying to help to do. And so, the systems of help that are there, in whatever way I can do that, I'm happy to do that going forward.
All right. Well, Chris, thanks for joining us. Great talk. Learned a lot, and
Great.
I hope that everyone in the community is on the Slack channel. Feel free to put questions there as well, and
Absolutely.
we'll
Yep.
be posting
So
some
the
resources.
is it
EDTC.
EDTC?
Yep.
There we. The EDTC community, the Slack channel, etc. Fantastic way to just do something more casual. Send me a quick note on the Slack channel. I'm happy to respond that way. Right. The website gets you into kind of the formal here if you want to like kind of set things up. If you've got little questions, or if one of your team members, you show them the video and you want to ask questions. I'm also happy, I can do like a small team support thing later on, but the Slack channel and the EDTC community is a great way to stay connected as well, because you'll get the benefit of everybody else's like additional comments along the way.
All right. Well, everyone, check your email. Next couple days, I'll be sending out the recording of this video. Thanks for joining us, and hope to see you at the next one.
Thanks, Lucas. Thanks, everyone.
Yeah, thank you.